So in this video, we're going to be talking about how do we write an equation to a sequence and then how do we find the next value. So a sequence is just basically a pattern, and the two types of patterns that we're going to be talking about in this class is arithmetic sequence, where you're just adding a number, and this is going to represent a linear equation because it's a constant rate of change of adding. And then a geometric sequence where you're multiplying by a number, and that's going to be, when I'm constantly multiplying by a number, that's an exponential function. So before we start, let's talk about just some general, just like wording that we use when we're talking about sequences. So just like with function notations, we use f of x, f of a, and all that stuff. With a sequence, we use s sub n, where you have this s and this n, and that gives you the term, like what term you have. So what is the pattern, the output of the pattern, and n is just basically your place in the pattern. So if I'm asking you for the first, the second, the third. We obviously start with the first term, and then we can keep going on forever because we're assuming that this pattern is continuing. So here we have three of the first terms in the sequence. So this is the first, this is the second, and this is the third. So if I'm talking about n, which is your place in your value, you have the place in the pattern. We have 1, then we have 2, and then we have 3. And then s of n is your, basically like your quantity that you have in that place. So in the first place, I have these blocks, and I'm going to count up how many blocks I have. I have 1, 2, 3, 4, 5. So s sub 1, I started out with 5. Then in s sub 2, I have 1, 2, 3, 4, 5, 6, 7. In s sub 3, I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So now that we broke this into numbers, so basically you start out with 5, then you get 7, then you get 9. So here, this is an arithmetic sequence because I am adding 2 to get from here to here, and then I'm adding 2. Well, when you're adding multiple times, basically what you are doing is, this is your slope, right? For every, like you're going up 2 for every 1. So my slope here is 2. An arithmetic sequence is a linear function. Now, in order to find your y-intercept, you have to go backwards, and I would have to find s sub 0. And if you go backwards, well, 5 minus 2 is 3. So that means that your y-intercept is 3. So if we were to write an equation for this in slope-intercept, I would write y equals 2x plus 3. But again, we're not using x and y in my notation. I'm using n and sub n. So right here, instead of x, I would have an n. Instead of y, I would have a s sub n. And so my equation would actually be s sub n is equal to 2n, sorry. Let's just erase that. So 2n plus 3. So that would be the equation that would represent any term in the sequence. So if we try to find the next term, well, we can find the next term by plugging in a 4. So 2 times 4 plus 3. Well, that means that I would be adding 2 4 times to my original value. And so 2 times 4 is going to be 8 plus 3 is 11. So my next term in the pattern is 11. So again, here, if for my fourth term, that's going to be 11, which we could have also gotten just by adding 2. So now this one, the equation is very necessary, right? Because this one, it's not adding, it's multiplying. So let's see. I have 3 terms, the first 3 terms of a sequence. So 1, 2, and 3. Well, for the first term, I had a 1. For the second term, I had how many triangles inside? Well, 1, 2, 3, 4. 4. Then for the third term, there's a lot more. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I have 16. Well, let's see. How did we get from here to here? Well, I multiplied by 4. And how did I get from here to here? Well, 4 times 4 is 16, so I'm multiplying by 4. So this means I actually have an exponential function here. Right, if I were to write my exponential function, well, we would start with our initial value, which we don't have here. We have to go backwards. In order to get my initial value, I would have n would be 0, and I would have to divide by 4. So that would be 1/4. I'm just going to write it as a decimal instead, so we would have 0.25. So my initial value would be 0.25. And then my growth value here is 4 raised to the x power. But again, we're not using x and y, we're using n and s sub n. So my equation for this would be that s sub n is equal to 0.25 of 4 to the n. So this is the equation that would get you the next term. And if I'm trying to find the next term, or actually let's make this a little bit different. Let's try to find the 5th term. So here I'm trying to find the 5th term instead, right? So we're going to put s of 5, and we're just basically going to plug in a 5 to our equation. This is the 0.25, right? And so then we're going to do, we can basically just go ahead and plug this in. So we have 0.25 times 4 to the 5th. And so you get 256. So s of 5 is 256. There you go. Again, you can have just kept going. So our 4th term was going to be 16 times 4, which is 64. And then our 5th term was going to be 64 times 4, which would have gotten you to 56. So this is just another way to kind of check that. So this is the end of this video. I hope that you found this useful. We're going to be using sequences, arithmetic sequences and geometric sequences a lot in geometry next year as well. So that's the end of this video.